just a streak of injection, you can see that most of the mass just like goes pretty fast right out. But if we look closely, obviously those flows are very complex, so there's some zones here that flow much slower. So if you look at that dye now, it's almost stopped at the bottom, right? It's going to stain those like eddies. So even in the surface, you know, there's some regions where it flows a lot slower than, you know, the mean flow basically. So basically whatever pollution we put in there, or nutrients or anything that flows through the river, actually takes a lot longer to be exported than you would anticipate. So now when you bring in the picture of the subsurface flow, obviously, I mean, you can already see some of those dye injection, and I'm going to do some more right away so you guys can see, you know, the difference between the velocity of the flow in the surface and in the subsurface. Right. Some of these side so we can see them, you know, evolve while you're here. Alright, that should be good. So one thing that should be pretty obvious right away is that the velocities in the subsurface, you know, this is a sand bed, so it's, you know, pretty fine sediment, so it flows really, really slowly. And again, this is important because when you have polluted sediments, which is, you know, a classic case where you have a drum of some chemical that explodes somewhere in the subsurface, and then it's going to be basically stuck there for a long, long time. So the question is, you know, how long is it going to take to be flushed out? And there's a lot of interest in understanding those processes. So one of the things that's, I guess, surprising about those, so what we call hyporheic flow or subsurface flow, groundwater flows, is that it doesn't flow really downstream all the time. So some of it, hopefully you'll be able to see it, but some of it actually spreads upstream. So you can see those bones here. And I'll show you, hopefully if I have some time, I'll show you some modeling that we do of this stuff, so you can actually visualize those flow paths. But all the mass is not actually moving downstream all the time. Some of it is actually moving upstream because of the water pressures, right? You have all those dunes, so that you have more pressure upstream than downstream. So in general, you know, there's a flow downstream. But because you have high pressure, low pressure, high pressure, low pressure, so some of that actually water is going to move from high pressure to low pressure going upstream, which is kind of interesting. So you guys have any questions at this point before I keep talking, like about, you know, what we're looking at here, or general things that about the lab? Are you guys interested in environmental engineering or other branches, or in general? You guys know what you want to do? Chemical, civil? Yeah, so usually environmental is actually considered a branch of civil in most places. So here the department is actually civil and environmental, so they're together, and that's been pretty traditional. Now there's a push to sort of separate the two because environmental is becoming you know, more of its own thing, I guess, like more separate from civil. And again, because of, you know, everybody heard of the droughts and the water scarcity, so that's one of the big aspects. And that's what we do here at Northwestern. I guess the common denominator between the professors here in environmental is really water. So they all do very different things, you know, within that realm, but they almost all are involved with water, some aspect of water. So obviously water is a big, you know, resource, and not only the quantity. So right now we hear about droughts everywhere in the U.S. So obviously the amount of water that we get is important for agriculture, for everything, mainly agriculture. But, you know, even when you have enough water, then the quality of it is another, you know, big issue. That's more what we're talking about here, right? When you have water flowing, you know, how clean is it? Is it, you know, safe? Is it sustainable? So that's really the kind of questions that we're interested in. And again, this is important for not only for quality for our use as humans, but also obviously for ecological quality. So you all know that, you know, I mean, a new use, I guess, of riverways is really recreational. So fishing, I mean, here in the U.S., fishing is recreational. A lot of places are actually subsistence, right? And fish to actually eat. So the quality of the water is also important for life, basically, in the river, which is also a resource for a lot of people. So again, I mean, the transport process, to go back to this demo, is really basically a lot more complex than you would think of.